Hi guys, it's Master Coach Tony Morgan, and today's video is on the Ideal Independent C30. So before we start, I just want to mention about a public warning. So basically, if you are a person who's looking to become an engineer, or you're doing your gas portfolio, or you're newly registered, well, this video is for you. If you're none of these type of people, unfortunately this video won't be for your satisfaction. So I'm just letting you guys know up front about my public warning. So the purpose of this video is to introduce new people about my fault analysis quadrant. So this fault analysis quadrant is to help people diagnose the right way using a framework which you're going to see. So I've got my student with me today. He's a new engineer, Naz, and he's going to help me go through the quadrant. We're going to go through it step by step, and you're going to hear and see how it's going to help this student with his diagnostics. So we're going to get inside the boiler first. We can take the cover off and then have a look, and then we're going to go through the quadrant step by step. So if you don't know already, on these Ideals, they have two screws on the bottom there, and they have the clips what pull off or pull down, and then this whole front end lifts off in one piece. So this fault analysis quadrant, a quadrant is split into four. So the four areas what we'll be looking at is no central heating, no hot water. We'll be looking at ignition fault, and then we'll be looking at pressure increase and decrease. So they're the four areas what we're looking at, and then we'll be drilling down into each one. So the first one we'll be looking at is the central heating, and we're going to be discussing what type of faults you'll get with no central heating. Okay, now so you've got your quadrant and you've listed what you're going to look at. So let's just go through the list what we've got. Oh, I'll tell you what we'll do, we'll just do it step by step. So we're going to look at the first one. What's the first one on your list for no central heating?
Room thermostat.
So you've got a room thermostat timer issue.
What timer?
Right, so customer calls you, says that they got no central heating. So it could be anything. So because you've got your framework to help you diagnose, so you look at your quadrant. So one of them is a possible timer or room thermostat. Yeah,
that's right.
So what would you be like looking at on this boiler? So this Ideal, what would you be looking at on the timer and room stat? What would you be expecting? Say like on this display here.
On the display, there should be a C on there.
Right, okay.
So say there's.
So this is your timer. So what we'll do first for heating, obviously we're going to turn it on here, like that, downwards. And then that would then go to the room thermostat. So if you're showing this room thermostat, if you bring it into the picture there. So this is the room thermostat. So obviously that would be turned up. So you hear that click. So your feed would be coming in here and then going back out to the boiler and then bringing on the C. So that's then making a circuit, and then you've got your central heating demand. So that's what you get first. So on your quadrant, you're making sure that is working.
That's right.
Yeah? Okay. Now, what if we don't get the C coming up on here, so that C doesn't come on? What would that mean? Do you think you know that question? Answer to that?
That means the thermostat isn't working.
Right. Okay. So the C's not come on, that's on, but no here, no C. So we look at the thermostat. So let's look how we could sort of test the thermostat. So if you bring the thermostat back in. Right, so what we would do on here, so we could take this wire, put it there, so they're linked together.
So basically bringing live 3 back onto live 1
Yep.
and joining it together and then turning it back on.
Well, you wouldn't need that now
Yeah.
because basically then you've linked them together,
Right.
and then if the C comes on, then you know it's the thermostat.
It's a thermostat.
What is the problem? Okay, so that's
Right.
a bit of fault finding on how you'd rectify if the C didn't come on after turning the room thermostat on. Okay,
Right.
right. Have you got a question you'd like to ask me?
Yes, Tony. So if we linked the live 3 onto live 1,
Yeah,
say it didn't come on then,
right.
then
Okay,
what
well,
would happen?
what would happen then? Well, if we look on our fault analysis quadrant, on that list, what does it have?
Right. So
On your list there, but if you looked
Yeah.
on your quadrant, what's on there?
so we'll go back to the PCB. So
Yeah.
this is always linked back to the PCB.
Okay, so on the list in the quadrant, it mentions the PCB.
PCB, that's correct.
Yeah, so that's where we'd look then. So, like you said, if this was linked together and the C didn't come on, then we'd have to
Look at the PCB.
PCB. Yeah, that's it. So just recapping now. So basically, on the timer room stat issue, we've just gone full circle.
That's right.
We've done the demand, the room thermostat. We've tested it. It did come on. The C was on. Then we looked at what if the C didn't come on, and what we would do with the room thermostat. And also we looked at, we've linked the room thermostat together and it didn't come on the C. And then we look on our fault analysis quadrant and it says on there PCB.
PCB,
So that then gives us a guide where to look next.
that's correct.
So you can see the framework of this. It's helping people like yourself get a bit more familiar and something to work to.
That's right. It gives you guidance of where to look next.
Correct. So what we're going to do now, we're going to look at the PCB. So we're going to go and, well, we'll basically take the cover down, and if this was wired to the room thermostat, it would be wired here like this. So you'd have the cables coming in here. So obviously it's got a link at the moment, but if you had the cables coming in, you're going to check that you're getting live going out and live coming back, and if you are, then it's definitely PCB because the power's there.
That's right.
And that should then turn into C on the display. So if that is the case, then you've definitely got a board fault. So just to help Naz just be clear on what I've just said, what I'm saying to you now, Naz, put your black on the neutral there, that one, so people see, that's it there, and then that on, yeah, on that one. So that represent your live going out.
Yeah.
And then you'd move the red over to the other one. No, not that one. Opposite this one here.
yeah.
Yeah. There, and that would be your live coming back.
Back. Yeah.
So you get voltage both of them, and that confirms.
You got 230 voltage.
And that should be obviously displaying C, and it's not.
No, then you know it's the PCB.
Yeah. So that's a test you would do. All right. Is
That's
that better
correct.
for you?
Yeah, that makes it a bit more clear.
Okay, cool. Okay, so now we're going to look at what's the next list on your quadrant in the central heating, no central heating.
Closed isolation valves.
Right, so what would happen on this particular boiler, especially on this one, they've got, it's the way it's designed, people might be losing pressure on the boiler and topping it up quite frequently and can accidentally turn off the flow or return isolation valves. So what can happen for you, they might not realise they've done that,
Right.
call you out. Now a symptom for that would be you turn on this room thermostat,
Right.
C comes on, no problem. Burn light comes on, fires up. But after about maybe a minute,
Right.
goes off. And then it might repeat that maybe after 2 or 3 minutes and keep doing that.
Right.
So you could, other guys who might not be as knowledgeable could dive in and get too deep in it and overlook something that could be really simple.
Right.
So you got to make sure that the isolation valves
Are in the correct position.
are in correct position, because what's going to happen, it's going to cut off the flow or return. The boiler can't circulate, gets hot and shuts down straight away. So you just simply make sure that the valves
Are in the correct position.
Yeah, before you go on to the next step.
Right.
So that's as simple as that. Yeah.
Okay. Good.
Okay. Cool. So another cause of no central heating, what could that be? What's on the quadrant?
Diverter valve.
Right. Okay. So what we'll do, we'll have a look inside here and I'll explain how that would work. So actually, let's just put this back up again. So it'd be a similar thing from I just said about the isolation valves closed. Everything's gonna, you can turn on, room start, C will come on, burn light will come on, but it'll go off after about a minute. What you'll hear is a fan speed rev up and then go reduce down, yeah, and then probably go off to nothing. So that's a kind of situation. Using your ears, you're going to listen for the fan speed, and if it starts diminishing, you know that something's getting too hot too quick. So once you do that, we can look at the divert valve. So what we can do, this is your actuator motor. You're going to remove the clip at the back like this. So you're going to take that off. Now what we're going to do, we're going to check this pin position here. So it wants to be out like that for heating and in for hot water. So we can carry out a test to make sure to see if it's in the right position on the right mode. So we carry out a test to do that, and depending what the result of that test is, we won't get too deep into it now, that will determine if this is a problem or that's the cartridge, divert valve cartridge is the problem. So we do that and then we'll find out what that is. Right, so what we're going to do now, I want you to just read me out the rest of the quadrant on the central heating so other people can hear what they are.
Right, as you mentioned, we just spoke about the diverter valve, and then we'll check the actuator motor, and then we'll also test the thermistors.
The thermistors, yeah.
Thermistors, which are on both sides. The PCB, which we've
kind of mentioned, yeah.
Yeah, and then we'll also check the pump.
Yep.
We'll check the potentiometers.
Yeah, the potentiometers, yeah.
And
the control knobs.
And the control knobs. Selector switch. Faulty flow turbine.
Yep.
Okay. And we'll check the block. We'll check to see if there's a blocked return filter.
Yep. Okay. Yeah. So these are like the possibilities.
That's right.
In the central heating quadrant, what you would check. So what's the next quadrant then? We're going to be looking at. I think it's the hot water. No hot water.
No hot water.
Yeah. So I just want you to read through the list of the possibilities of no hot water.
Again, we'll check the flow turbine.
Yeah.
Or the flow switch. In this case, it's got a flow turbine. The thermistors.
Yeah.
Potentiometer.
Yeah.
The diverter valve again. The actuator motor. The pump.
Yeah.
Blocked return filter.
Yeah.
And hot water, the plate hot water heat exchanger.
Yep.
And again, PCB.
Yeah, okay, cool. So that's the possibilities in the hot water quadrant. All right, so on the next quadrant, what's that one? That's ignition failure.
Ignition failure.
Right, okay, so let's just run through quickly
So
what the possibilities are.
On that, we'll check the condensate, if the condensate is blocked. If the gas valve is blocked or faulty.
Yep.
If there's gas supply coming in.
Yep.
If the injector is blocked.
Yep.
The spark electrode, if there's a gap and if there's a spark gap, check that. The flame sensing electrode.
Yep.
The spark generator, ignition lead. We'll also check to see if the burner's faulty. If there's any issues with the flue, any flue problems.
Yep.
We'll check the fan, air pressure switch, and then again we'll check the PCB.
All right, cool. So the last quadrant, what's that one?
If we're losing pressure or pressure's increasing.
Okay, so what would them possibilities be?
Expansion vessel. Expansion vessel pipe could be blocked.
Yep.
PRV. Diverter valve cartridge. Check to see if there's any leaks in the radiator valves, hole in the radiator, check the pipe work, check the main heat exchanger, see if there's any cracks or holes, check the filling loop, and again the plate heat exchanger.
Yeah, that's it, correct. So yeah, so basically we just done an overview of the fault analysis quadrant. This basically guideline, this framework, what you can use for your diagnostics, especially for new engineers. So that's going to be the end of this video. Hopefully you learnt a lot from watching this, for the people who I mentioned earlier. Okay, so just before we go, just want to go over a few things before we end the video. So basically, if you're thinking of becoming a gas safe engineer, you want to get into the gas industry, or you're doing your gas portfolio, or you just completed your gas portfolio and you're going to want to be gas safe registered, well, basically I've got a great opportunity for you guys, for you to become the best engineer you can be. And that means you're going to be at a higher level than the average gas safe engineer out there. So all you got to do is click on the description button below this video. I'm going to show you how to do that. It's super easy. So all you need to do is click on the arrow here, which I've shown you, this little down arrow. Click on that and that will bring you into the description part, where then you can go into the website, click on the link and find out more about becoming a great masterful engineer, or how you could get into the gas industry, or how you want more help with your gas portfolio. So just click on that link and you'll find out more about what we do. So that's going to be it. Also, one more thing, if you haven't subscribed to our YouTube channel, just click on that subscribe button there. That's the arrow pointing to it. Just click there to subscribe, and then you'll be kept up to date for any future videos. So that's it, guys. Hope you enjoyed it, and we'll see you in the next video. Bye for now.